All right. So today what we will do is we will continue the discussion about Lambda and AWS Lambda in particular. So my first question to you is, when would you use a Lambda function, for example? Where could you use it? Any ideas? So in your projects, where would you think Lambda would kind of fit? Yeah?
Well, it's not in the project, but in general, you can use it as arguments to other functions, for example, to decide what kind of processing you're going to.
Yeah?
Or you can return it from a function if you want to, like, dynamically save the state of the function call up front, and then you get out a function that takes no parameters, that is created based on the parameters you gave it, and then you can pass that around with the parameters predefined.
In general, yes. So that's true. Usually you don't try to. So generally, when it's best suited is when you have some internal event which triggers some processing, and you don't want your core business logic to be engaged, right? So when, for example, someone like in assignment 2, when you have to count or you have to trigger a callback to a webhooks when someone was calling an issue, so your issues and your normal API kind of gets a call, and then that triggers an event which makes something happen with the rest of the web server. Then what you could do is you could write your webhooks notification using a Lambda function, which is triggered by the event of somebody else asking your API, right? Or, yeah?
And now we're talking about Lambda functions
as cloud functions, yeah, that's right.
But can you mix and match cloud functions and
like a normal functions? No, you kind of can't really, because the Lambda functions, the AWS cloud functions, say, just not to be confusing, they have a different pipeline of accepting parameters and passing the results out, right? So in your code, you could use Lambdas as was discussed, for managing the state or passing things around, but the Lambda functions in AWS, they don't have state. They are kind of stateless. So you don't really want to do that. It's too heavy to do that. What you want is you want to kind of offload the processing of some events to something else that you don't want to deal with. And then, because, for example, you don't know how many webhooks you have to handle, right? And how long the callback will take. So when you're dealing with it yourself, you have to provision the resources, and you have to provision how you're gonna handle the load balancing and everything, right? If you offload it to AWS, then they do all the provisioning. So if you called a particular Lambda function once and it's busy doing something, and then there is another call and another call, AWS will provision enough resources to handle all the requests, right? And it happens automatically. So it's quite nice, because you can't really know how many webhooks people will register with you. And then this scales automatically for you, right? Another useful thing is, for example, when you're storing an image in a database. So you have an application, and then people take photos and can submit an images, right? You have some sort of app that allows people to store images. And then they do that. So they take a snapshot, photo, and then they send you the blob, the binary data, right? So now, usually what you need to do is you need to scale it and format it and do something with it, so it is in a standard format in your database. So you may be generating a thumbnail preview of the image. You might be scaling it to some standard size. you might be checking the contrast or whatever, applying some filters. All this behavior can be triggered by the event of you storing an image in the database, and that could be a Lambda function, right? So every time you have some sort of event that you need to deal with, you may think, oh yeah, that could fit into a Lambda function. Typical requests, like a typical business request that your application handles, they can also be done using the web API as cloud functions, but as we were discussing yesterday, it has some disadvantages in terms of management, in terms of deployment, and in terms of managing the state. Yeah.
But can you mix cloud functions and say an Apache web server? Can you?
Of course.
Yeah. Okay.
Yeah, of course. That's how you should do it. So you should have some sort of reverse proxy, Apache or Nginx, which kind of directs some of your logic to cloud functions and some of the logic to you, right? And that's perfectly reasonable. Exactly. So that's for assignment 2. If you offloading the management of the webhooks to a cloud functions, then in your reverse proxy, you would say, okay, those URLs go to me, to the Go server. Those requests go over there to the cloud functions, right? And that's perfectly reasonable thing to do. Another thing is when you're developing something that you want to isolate, you want to decompose your monolithic application into set of microservices. Then you don't want to have a single binary. You want to have multiple binaries so you can iterate over the microservices independently, right? Then some of those can become cloud functions. If they are small enough and if they have some nice event pipelines, then they are perfect candidates to be designed and done as a cloud functions, right? So those are the typical use cases and typical scenarios. What we will do is I will show you, I will show you how to actually do this. And then we will talk about the disadvantages. So what sort of disadvantages we already talked about? So one is that there is no versioning for the deployment. So when you deploy to production, when you deploy to AWS, you have to take care of versioning yourself, and you have to make sure that you're not making mistakes, that you don't redeploy something that is not the correct version. There is no checks and there is no safeguards to help you with that. So that's one. We will talk more about the other ones later. So how can we write the cloud functions? We have to choose what runtime we're gonna use. So of course, our binary, our code needs to run somewhere, right? And we can choose some of the languages that we can create our Lambda function in, and then we see what sort of operating system it will actually run on top of, right? Why do we need to care about this? Well, because, for example, for Go, we actually have to generate a binary for Linux, right? As you see, all operating systems for cloud functions are Linux, which is not surprising. So then what we will do is we want to write it in Go. So we'll go to Go, and then we go to how to write a Lambda function, and that's kind of pretty much the code which they provide as a simple example of creating the function which will handle your requests with some JSON and produce the text result as an output, right? And as you see, it's not it's actually, it looks very nice, right? So what we have a function which takes the normal context from Go and the struct, which is our type, and it produces some results. So it can produce a string in this case and an error, and then we just call lambda start and register that single function. So this pattern is very similar to your handler functions, which you used with HTTP, right? Server. So this sort of is like the HTTP handler function, and this sort of manages all the magic. So all the magic actually happens in this package, which is from AWS, and the logic that you need to do is pretty straightforward, right? So I have done that tutorial before. So I'll go to projects. Lambda. So I've done it, but to make it a little bit more interesting, let's just modify it slightly. So don't update my tools. All right, so we have the same example. Yeah, by the way, when you do this, so you create your file, then you call go mode init, and it will create the module file for you with the up-to-date version of the dependency that you need to use. So you should not reuse this. I mean, if you're doing it like, this week, it doesn't matter. But if you're redoing it like after some time, you should not have the go mod file at all. You just call go mod init, and then it will generate the file with the appropriate version for you. So you have the version that you should be using. So let's modify it slightly. So I will have a name and an account, which will be and simple int, and I will have an account parameter. So then what we can do is we can change our print to say deposit done, previous value, new value. Okay, so we still produce a string, but we want to do a little bit of logic, right? So what we will do is we'll have deposit event, and our deposit event will say for this person do a deposit. So then what we will do is so we'll have the new account, and
it's called deposit and not name.
yes, that's right. So yeah, let me do this first. So we have we don't have the old value because we don't want to really keep track of who is who. So when I'm printing, I will just say deposit done, value this. So because we don't, I would have to keep a record of what the person had before making a deposit, right? I don't want to complicate the example too much. So yes, so I just do that. So normally we should look up the deposit name and check and add the new value to the existing. Make sense? So like I'm using this as a kind of a primary key. So we have people and some sort of a banking system, and we're saying, okay, Mariusz should get extra 100 krona, right? So here I should look up Mariusz, check how much he has, print it, because we wanted to print the previous value, add the new deposit, and then store it in the database, right? We're not doing that, we're just printing the message, right? So we say deposit done for, and then we'll have the name with knock. All right, so then we will say deposit name, deposit account. All right, so what our function does, it basically expects a certain event as a JSON, and then it will just print the stuff out, right? We don't really have any logic here, but you could imagine just writing more complicated logic in that single function, potentially using some libraries or using something more complicated from another package. And then we're just registering a single handler, and we pretty much done. Right, so it complains that account is not a string, so I should have a value instead, right? So the linter was telling me you're using string for string and string for an int. You should not use string for an int because int is not a string. So yeah. All right, so let's that's saved. So if I say go build, it builds. And it generates an executable called IGC analysis. I'm using a particular name. Well, I could deploy it, but remember we have to compile it for Linux, and I'm on Mac. So my executable is Mac Mac OS executable. So how do I do it so it's Linux? Yep.
When you do the Go build, you can say if you start the line with the Go OS equals Linux, and then
exactly, perfect. So that's exactly how I will compile it. So I'm setting kind of environmental variable Go OS Linux, and then building it again. So now I will build it for Linux, and then if I check the executable file, it says, whoa, it's not Macintosh anymore. It's ELF, which is a Linux executable, statically linked, 64 bits, perfect. So now what I will do is I will say zip, and I will create a IGC analysis zip file, and I will put a single executable into the zip. I will go to my console, and I will upload a zip file. So I will pick it, choose it, and save it. And then it redeploys. I probably need to log in. Yes. So it redeploys. I'm kind of not sure if it actually redeployed it, so I'm gonna do it again. So then that's the problem. Like I should have some versioning here, so I know what current version is actually deployed, so I could check it with some thing, but I don't. So anyway, so I have it. I will configure a test. So I have a test with a Joe. I will test. So I will change. So I will create a new test, and I will say my deposit test, and then we will say we have Anna, who is gonna get. We called it account, right? Yes. So the second parameter is account, and we give her 300 krona. So now I have a test data, which is my simple JSON with 2 parameters, 2 attributes. I will save it, and then I can pick this test and run it against my my deployed cloud function. So when I run it, it provides me here the details, and it says the execution succeeded. I can see the logs of how the call happened. So we are here. So we have, the latest version, a request and a report, and we have, I will come back to that. So if I provide the details, I see what the function returned. So it returned a string, which is what we expected, right? And we have some details here. So those details are kind of the same as here, but formatted a little bit nicer, right? So one thing that you will realize is that it took less than 1 millisecond for this simple function to execute, right? Instantaneously. It's like, it's really not, there is not much logic here, right? It just takes the parameters and produces the response with the string formatting, right? Very streamlined. So the function took very little time, but I am billed as if I used up 100 milliseconds, right? That's the unit of billing. So normally, if your functions are kind of time consuming and then take substantial amount of time, rounding up to the 100 milliseconds might be acceptable because it will be a small percentage of your total usage time. But if your functions are very tiny and very fast, then you will be overbuilt. Like I'm like, 100-fold paying for 100-fold more to what I'm really using, right? So then it's pointless. Like you should not do that, right? So you shouldn't use this particular setup for functions which are really small, because then you totally overbuild. And then you see that everything works fine. The deposit is done, and we sort of achieved what we want, and we can just keep it running. So it's running on AWS now. It's deployed, and it can be used with whatever triggers I set it up with, right? So if I go here, I can test, because I configure it so it can be triggered by the HTTP request, right? So I can pick how I want to test it. So I may say I need to pass a parameter to it. So I need to set up, like, it's like a postman, right? So I'm setting up potentially parameters into the URL. I'm setting up whatever I want in the headers, and I'm setting up the body, right? So if I set up the body the same way as we did with the previous test, so I need name Anna and account 300. I can kind of run the test now on the deployed code, but using the HTTP gateway, right? Correct? So I will run the test, and we see that we have the body request. And we have the response, which says it didn't work. We got 502 error. So the server kind of didn't correctly responded to the request the way we were expecting it to, right? So this is, I don't think I can see that in a nicer form than this. Yeah, so if I, if I run, just let me run Postman again. So to be a little bit clearer with the, because this one, yeah, so I have a summary here, right? So there was a 28 milliseconds latency, and then the response I got from doing the post test is internal server error. There are no headers, and there is, it kind of didn't work. So when, yeah, so I cannot run Postman. I have the old version and it doesn't run on anymore. So let's stick to this. So I have a little bit of an issue and I don't know why. And you know, how long did it take us to follow this tutorial and get it going? Like, you know, 10 minutes. So we just knew this will work. And we tried it with the normal call before, with the normal test, and now we're doing the API gateway. And unfortunately, they don't have sort of a nice example for using the gateway API. You have to kind of work it out yourself. And it turns out all those trigger points. So if I go back to, no, I need to go back. Oh, come on. So all those trigger points that I have here, they own wrapping of parameters, right? So all of them will have a particular type of input JSON that they expect to achieve, and then they handle it appropriately, right? So for the simple test that we had with the yes, oh come on. So for the simple test that we currently have, here I'm only expecting a JSON with 2 parameters, and when I tested with this test, the deposit test, it works. But if I use anything here which expects a certain parameter format, then I have to comply with that parameter format, right? So it turns out that API gateway wraps the body inside an outer layer of JSON, and I need to do the parsing appropriately, right? So we will go back to the code, and I will go to Lambda Web API. Let's close this one. So after, yeah, so the original example took us with Chris less than half an hour to work it out and to have it going, and everything was fine. This one, it's as short. It looks as simple as the previous one, but because of, first, we didn't know why it was not working. Second of all the documentation was not that well presented, and then working out what the actual API gateway proxy request looks like took us a while. So as you see, when I'm handling API requests, I don't have context and my JSON anymore. I have a particular type, which is events API gateway proxy request, right? So I have a different struct which will also be a JSON, which wraps my actual body of the request inside this particular struct, right? And you can see it has a number of parameters which kind of mimic HTTP request, and one of those parameters is the body, and the body will be the JSON that you injected, right? So you get the idea here, right? So you have the inner struct, which is embedded into the outer struct, which is provided by the framework. So the API gateway kind of manages the outer layer with all the headers and everything, and your body kind of gets injected into the body of the request, right? So the body will be here, right? So then what I can do is I can again have I can modify that to be the format that we expect, and I will say it's deposit event. What I'm doing wrong here?
You need a comma.
I don't need a comma, yes. And then I will have my deposit. Yeah, let's keep it as an event. And then I will say again, I will send deposit to event name done with event account knock. Yes, I cannot. How do I convert?
strconf.i2a. Capital I.
Yes.
Package is strconf as a string convert.
Correct. Conv. Yeah, so we have, let's split the lines. So I have the response this way. Is it better to do it this way, or is it better to do the way we've done before with the sprint?
Matter of style.
Matter of style. Which one is faster, do you think?
The sprint.
Sprint will be faster. Which one is safer? What if this one fails? What will happen? It shouldn't fail, right? Doesn't return error or anything. So if it fails, it sort of should just return an empty string, right? It shouldn't panic. But do you know, are you sure it will never panic? Yeah, so it's a matter of style. I have slight preference to sprint. It feels a little bit more tidy, and also it feels a little bit more informative of what exactly you're doing. You're basically putting some variables into a string, right? When reading this, it's like, I'm not quite sure what you're doing here, right? You're kind of doing the same thing, but it's a little bit more explicit with a sprint. No huge preference though. All right, so we handled our body. So we created the new body, which will go back to the caller, and it's again the same thing. So what happens is you have the request, which is your sort of HTTP request, which you will get the body out of. So we kind of marshalling the body of this request into our struct here, so we can access the fields. And then on the response side, again, before, remember, we were just dumping a string. We were responding just with the string. now we cannot respond just with the string because the response is HTTP response object, which has headers, content type, and all the other things, right? So we have to wrap our body into this response object. So that's what we do here. We say, okay, our response object will have body, which is just a string, and we will say that the type, the content type of the response is text plain, right? And then again, we just register that particular function, right? So depending what events you're consuming, you have to tailor this function parameters and return types, so the function signature, to the basically to this, to what you're consuming here. So you cannot write a universal function which always accepts the same things, because these guys dictate what is being fed into your function and what is expected out, right? Which kind of makes sense, because a API gateway will have kind of a more it's a layer above the internal messaging or event system, because it needs to pack it up into the HTTP protocol, right? So if I go back and I do the same build which I did before, so I will build it. I will zip it, and I will redeploy it. So I will pick this zip again. Oh, I probably picked the old one. Let me double check. Yes, I picked the old one. So I need to change the folder. This one. So now I save. I will have redeployed my new function, right? So what will happen if I test it with my deposit test now? So if I test it here, what will happen? Yeah, so my code will be running. My deposit test has a JSON. So remember, it has this JSON as input, which it will be passed into the function, right? So the function expects to get HTTP request struct. It will get this instead, right? So there will be a type mismatch. It will try to parse this as a HTTP thing, and it will kind of not find the body, it will not find headers, it will not find all the things which it's supposed to find, right? So then the parsing itself will probably not fail. It will say, well, we kind of didn't find anything, unless you have like compulsory fields which it has to find, and then it will fail. So depending how they've implemented it, on that path, it will not be able to parse it, and then it will either execute the function or not, right? So if it executes the function, it will execute the function with empty body and empty everything, because it didn't find anything. And if it fails, it fails. But if it executes it, then we will not be able to, in our code, we will not be able to do parse the body, because the body will be empty as well, right? So let's run it and see what's gonna happen. And it kind of didn't fail, right? It says success. We actually completed the call, like your function ran fine. So how fine it ran? Well, it ran fine. It executed. The function produced 200 as a result, and it created the text plain, and it even created the body, right? So what it means is we actually executed this with the empty structs that we thought we're gonna get after parsing the wrong JSON, right? So everything we got here was empty, which means the body was empty, which means when we parse it, we got an empty event, which means we got name, which is an empty string, and account, which is 0, right? Correct? And that's exactly what we see here. we say deposit to an empty string done with 0 knock, right? So, and then the code ran for 2.7 milliseconds, and again, we were built for 100 milliseconds. So it kind of tells you that even if the function gets a wrong parameters, they kind of are not panicking, they're not crashing the server, they basically handling it as if the parsing of this JSON struct here succeeded, but it didn't fill in the request. It basically populated the request with the default struct elements, right? Does it make sense? Right. So now if we so now we kind of lost this ability to test it here, right? The tests here don't work anymore because they expect a different struct. They expect for my test to work, I would need to create a test event, which instead of this has what? Has an outer JSON, and it has body which has the inner JSON, right? So if I save this, my deposit test, and rerun it, so now we actually crashed it. So now we crashed it because we cannot unmarshal the JSON that we created into yeah, I need to read the error message. Yeah, so let's check what this body is a string. Right. So body needs to be a string. What is body in our test? Is body a string? Yeah.
It's an object.
It's an object. It's not a string. Let's fix that. So if I escape this, it's gonna be a bit complicated, isn't it? But not impossible. Let's try. So now, oops, actually, I should not be escaping the first one. So now I have a body, which is a string. Correct? Any errors? I think looks correctish. So let's save. What? It complains. Yes, it complains because this. All right, so save. Test. Woohoo! We fooled it, right? We have Anna and we have the deposit, and everything works fine, right? So we kind of now have a struct which kind of parses correctly as the request, API proxy request, which we can extract the body from, and the body is our actual message, right? All right, so I just do one more test. So we will go to the API gateway. We go here, and we run the same test with the so what we will do now is we run the test, and again we will not we will say we doing post. We have to type. So here, should I use the request? Should I use body, or should I just use the plain name and account? Yeah.
Just name an account and so it's automatically wrapped in the body.
Correct. So it's just body, right? It doesn't ask me for the outer thing. The outer thing is all here. So the method, the path, the query, the headers, it will wrap it for us, right? So I just need this. If I run the test, I have 200 now, and I have deposit to Anna done with 300, right? So it works. So that kind of is a simple, and then we have how long it actually took. So here, it's not only the processing itself. So when the test, so you know, when we call the test with this one, we internally pass the parameters, execute the function, and get the result. And it measures the time of how long the function runs, right? So if I do the test here, I have this, which is the time it actually takes the function to run, right? So why here we have half a millisecond, and here we have 35 milliseconds, right? It's like, 70 times more. Why is that?
Routing.
Yeah? What else?
Yeah, so now it has to pass through the API gateway, get routed to the function, and from the function back to the API gateway.
Exactly. So it's the all time which is spent on the pipeline to get the whole chain done, plus the time it actually takes the function to execute, right? So that time is included here, but it's like small compared to the time that the rest of the routing takes. And then we have some details about what happened and so on and so forth. With the API gateway, the way I configured it is that we have this. Yeah. So. I have the point of entry, and the point of entry can be called by any method. So I can do get, I can do post, I can do everything. It will be routed to me. I can restrict that. So I can say I only want post to be routed, everything else should be rejected, right? So AWS will do that for me. And then the second thing is I can restrict who can call it. So currently it's open, so anybody can do the call. So you can have your web server kind of making calls to it without authentication, but you can restrict it as well. So you can restrict it to only registered users or authenticated users or users with a particular API token, and then everything else will be filtered out by AWS, right? All right, so let's have a break. Let's have a 10 minutes break, and then we will wrap it up with some gotchas and some limitations of the cloud functions.
Because here it would be really unfair because the tech guys would know it, right? The
That's right. So
operations
half,
completely
yes,
would know it.
that's
They
right.
wouldn't blur. And the other ones, what the heck is going on?
That's right. All right. So let's return to our simple example. Oops, sorry. Where are my slides? Here. All right. So the workflow. The workflow is simple. You have to first identify what is the source of your event, right? Then, based on this, you will have the input struct, and then the rest follows. You create a simple function workflow that accepts the parameter, produces the result, and then you deploy it using the binary zip thing. You need to take care of the versioning. You need to take care of the making sure that you isolate your binaries. So maybe keeping it in separate package. If you're working on a more microservice type deployment, then it will be natural. Yes, we don't want this. Right. So the idea here is that everything we did today was using mouse clicking, right? So I click the mouse many times to have the demo running, right? You can fully automate it using the web API and the console commands. So you don't need to click things. You can kind of fully automate it with the command line, right? To have the deployments and everything automated for yourself. So we will not do that. It's left as a homework for the very keen students who would like to use Lambda functions. All right, so then we have some advantages of running Lambdas. So one is that when your Lambda is not being executed, like you deployed your app as Lambda functions, and then nobody's calling you, then what are your costs? Your costs are zero, right? What if you rented Heroku, or if you rented EC2 instance, and nobody's calling your server? You still need to pay monthly fees for running the instance, right? Provisioning the instance. Even if your instance is not actually instantiated in AWS, you still need to pay monthly fees for just in case somebody calls you, they will instantiate it, right? With Lambda functions, no costs. Nobody's calling you, you pay nothing. People calling you, you pay per usage, right? Auto scaling, so automatically they will provision more resources the more requests you're getting. You don't need to do that. Accessible all the time, like same as with any cloud solution. You can really modularize your larger apps, right? So you can split your larger apps into more manageable, deployable components and isolate it, right? So that's what we were discussing yesterday, that if you, for example, want to upgrade your webhooks, you need to upgrade everything else because it's a one monolithic binary that you deploy, right? So your server will have kind of a turnover on everything, even though almost nothing changed, but this one small part changed, right? If you isolate it into Cloud Functions, everything continues to run. There is no downtime, but you can update just one function at a time, right? You upgraded one module, one functionality, not touching anything else. So you have a better isolation. You can have new business models for offering cloud solutions or for yourself, like charging depending on the usage. And you have all the built-in monitoring and so on, again with the API access to it. So you can automate kind of monitoring yourself because you have all this data as events coming to you, right? So what are the disadvantages? Yeah, the rounding to 100 milliseconds is somewhat problematic, right? Where else do you remember this? Not to 100 milliseconds, but the rounding problem being a problem. So in the old days when the telephone networks were introduced, they were not able to bill you per second. They had to bill you per minute, for example, right? So they were rounding calls to a minute. So if you call someone, it's like, are you coming? Yes, poof, you put down, you were charged for the whole minute as if you talked for a minute, right? once the billing systems got upgraded and they were actually able to monitor the calls in real time, they could do a kind of per second, per usage billing, and that was a big deal, right? Because this billing for per minute was very unfair, there was a period in history where the operator said, okay, we know it's unfair, so for long distant calls, like if you're calling a different country and your call is really, really expensive, they said the first like 2 seconds, 3 seconds are actually free, because sometimes it's a mistake, or sometimes the call kind of seems like connected but not connected, and so on. So they said, okay, for 3 seconds we will not charge, and then we start charging per minute, right? So actually you could use that, because you could call someone and like do a series of very short calls, and that was actually free, because they were not charging you for like just the first 2 seconds, right? Versioning, I think this will be improved, so watch this space because it has to be. Deployment workflow kind of has command line automation, but you have to do it yourself. I don't know, I haven't tested the recent AWS command line tool libraries, whether they already have everything in, but again, that is something to be watch this space, yeah?
Are people doing test-driven development with this approach? It seems kind of tedious.
Kind of hard, yeah, exactly. Watch this space. There is, so it's a very good question, I don't know. There is a lock-in effect a little bit. So if you write your functions for AWS, then it's a little bit hard to migrate quickly to Google Cloud Functions or to Microsoft, right? If you wrote your servers in a Dockerized form and you have your containers and you're just renting a VM, migrating your deployment from AWS to whoever is kind of easy. Everything is just a VM, right? But here you have this a bit of a lock-in effect because the parameters and all the events and everything are kind of tied to that particular platform. And then there is a complicated use case with databases. So yeah, I will kind of very quickly talk about it. So when you wrote a function, cloud function, which calls your MongoDB, right? So this cloud function, so somebody calls you, you doing some logic, calling your MongoDB, so opening a connection to a MongoDB, and then you finished. So you replied to the client, and then there is a new request coming to your cloud function. This new request will not come to this instance of the cloud function, it will come to a new instance of the cloud function, which will also open a connection to the database, process the request, and answer the response, right? So AWS will kind of instantiate your cloud functions every time there is a call, right? Because that's how they work. And then they need to garbage collect this, right? So at some point, they need to garbage collect the previous one, which is not used anymore, right? But it doesn't happen very fast. So if you have a lot of incoming calls coming in, and they scale it up to handle your request very fast, so you have multiple instances, and then all those instances make requests to your database, and then some of them are not garbage collected yet, and new ones are created, then you at some point will overfill the limits of how many open database connections you can have on your database, right? So you need to somehow deal with this and make sure that your database connections are closed and tidied up in your code so you don't overfill the limits. So the persistence with external databases is a little bit complicated. All right, do you have questions about this? I think we covered it yesterday and today, and it's a relatively straightforward topic. So this 100 milliseconds is kind of an indication of quality of service, of service level agreements, right? So for example, if you go to AWS and you say, I want to know how much time my service will be down because of you, right? So what does it mean that the server is up or server is down? Semantically, what does it mean? So someone needs to monitor if the server is up or down. If the monitoring cannot tell if the server is up or down, is the server up or down? How do we count that time, right? So if I monitor and I check and the service is up, okay, it's up. If I monitor and the service is down, I'm saying it's down. But sometimes I'm monitoring and I don't have the answer yet, and I'm not sure if it's up or down. During that time, do I count it as down or up? Yeah, so it's a little bit problematic, right? Also, how long can you be down or how long can you be up? It's kind of an agreement. So if, for example, if I say 99% of the time the service is up, what does it mean? How much time per week, per year, the service is down actually? Right? You can calculate that, right? So depending on those service level agreements, you have to deal with the with some of the properties of how you're agreeing with your provider or with your customers of what certain things mean, right? And that's called service level agreement. So there is a there are lecture slides. That's the wrong. Yes, that's the wrong course. This one. So for next week, we have prepared the lecture slides about service level agreements with the 2 videos discussing the topic. And the service level agreement is relatively straightforward. And if you browse the slides, it will be self-explanatory, right? So this topic is simple, and you will do it next week on your own. Unfortunately, neither me and Christopher are in Jovik next week, so we will not be present during the class. So there is no lecture on Wednesday. You just do the videos and the slides. On Thursday, Yone will come and you will have the final project support. So people who need some help with their projects, they can come and talk with Yone. There is one topic which we should spend time on, but we kind of run out of time, and that's Osi Layers and Networking. It's a topic which is a catch-up topic for those of you who didn't have networking. So usually it happens a bit earlier in the semester because it kind of lays the foundation for the HTTP discussions on HTTP and so on. So what is networking, how the networking works, what's, how the protocols kind of work. Unfortunately, we will not cover this topic, so we will not have this topic in the exam, with the exception of the layers, okay? So it's a little bit superficial just to talk about the layers without going kind of in depth into the protocols, but the idea is that you have kind of a layered model on how you're roping the data depending on where it is being transmitted. So if you think about it, if you're writing an application, you're interested in JSON, for example. That's what we did. We have an application which was accepting JSON and producing string. And that's the layer which we think about, right? We don't consider anything below that because we don't care what happens below. What we care about is that we get a JSON and we produce JSON or string, right? So this is called application layer, and that's kind of application-specific data. But then this data needs to be formatted somehow so it can be transmitted over the wire, right? So at the bottom layer, we have the actual physical cable or physical fiber optic cable, which needs to pass bytes from one endpoint to another, right? So we have on the top, most abstract level, we have the applications. And then on the lowest kind of infrastructure level, we have the bytes kind of passing through some sort of medium, right? And we typically do either 4 layers or 7. So with the 4-layer model, we talk about the application, and then we talk about the logical nodes which provide us the reliable connectivity between the endpoints. And that's what we call transport. And on the transport layer, we know the ports and the kind of destinations of where things go, right? So in the transport layer, we know the details of who will read and write the messages. Kind of on the IP and port level. On the network layer, we know the IP addresses of the nodes which will get the data. So the host or the network layer is the internet protocol, IP layer. Here we have a kind of a TCP, reliable connectivity layer, and then we have applications. And then the network interface layer is the MAC layer or the hardware layer, which is the Ethernet or fiber optic protocols or what have you on the kind of the lowest level of abstraction, right? So we have those 4 layers, and it's not as if it's just the abstraction, as it's just the semantics. It's actually implemented in a way that those protocols kind of wrap each other, right? So on the highest level, we have this wrapping which wraps our JSON into HTTP packet with some HTTP headers and body and so on. We kind of discussed that in the course. And that gets handled by an additional wrapper which handles the TCP layer, and then another one which handles IP layer, and another one which handles the kind of the infrastructure layer of delivery. And as the packet transfers from bottom to the top, those layers are kind of stripped off, right? So it's like an onion, right? So when we are here, we only talk about HTTP. We don't care about anything else, right? But as we go here, we get additional TCP headers. As we get here, we get IP headers. We need to know the IP addresses of where things go. As we get here, we get to the MAC layer. We know exactly which routers and how the packet's gonna go, right? So we get all the extra headers in. And then as the packet gets delivered to its destination, it kind of unwraps again. So it unwraps back up to the HTTP, which is the kind of the application layer protocol, right? So this you need to know. And this might be on the exam, right? Who of you had networking before? All right, for who it's new, like you never heard about this before. Yeah, so if you will have questions, ask Yone or us, and check the Osi layers and kind of understand, like, do you conceptually understand this? The kind of a wrapping and wrapping up and wrapping down? You know what IP protocol is and TCP? Or no? Right. Yeah, so Christopher was saying that it might be too much for you to kind of go through that on your own. So we will not have it in the exam, okay? You should go through it on your own anyway, because it's worth knowing. But you shouldn't be stressed that we didn't cover it and then it's in the exam. We will kind of not have it in the exam because we ran out of time to have it in the course. But the OC layers, the 4, so the interface, network, transport, and application, with examples of those protocols, or 7, where we have a little bit more detail of how the wrapping of the packets actually happens. Those are kind of a fundamental things that you should refresh yourself or upskill yourself if you didn't know it. It's a little bit unfortunate because some students have it, some students kind of have networking which take this course, some don't, right? It will be more unified next year because everybody will have networking coming into this course because we have a compulsory networking course in the first year. But for this year, it's a little bit of a mixture. So first, we ran out of time a little bit, and second, it is kind of a heavy topic to cover in a the end of one of the lectures, but it's important enough that you should know about it, right? So those students who know about it, please refresh yourself about it. Those who don't, please check the slides, and I will put a video from last year's lecture. Check it out, but we will remove it from the exam. We will not have that part in the exam this year, okay? All right, so do you have any questions? If not, thank you very much, and we will see you not next week because we out, but the following week I will announce when we will have the project presentations. About the project presentations, it doesn't need to be long. It can be kind of a show and tell session. You just demonstrate your project, like what you've done. You can show some code, like if you are proud specifically about some solutions that you've used, then you can show the code. You can show the kind of a demo of how it runs and what it does, and talk a little bit about the reflections, like what was easy, what was hard, what you're proud of, what would you could improve. 5-10 minutes. You don't need to have slides. You could if you want, but you don't have to. You can kind of do just the presentation with the demo. All right. Anything else, Chris?
No, good.
All right. So thank you.